What's going on, guys? In this video we are going to talk about the number system. Let's talk about decimal first, the one we use in daily life. Decimal is basically the base 10. For decimal the base is 10. Now let's look at a number. Let's say we have 294 and this is decimal, and if you look at the places, the first place is, for decimal the base is 10, so 10 power 0 is the first number, that is equal to 1, and the second number represents 10 power 1, that is in the 10th place, and this number is in 10 power 2, that is equal to 100. So in order to calculate this number, what we do is 10 power 0, that is 1, right? So 1 times the number in that place, that is 4, plus 10 times the number in that place, that is 9, and 100 times the number in that place, that is 2, and if you multiply and add them together you will get 294. So that's what these places represent, and that's how we got this number. Now let's look at another example with some decimal points, a fraction number. Let's get rid of this one. Or let's try this one right here. Okay, so you can compare both. So let's say we have 15.214. now we know that this is 10 power 0 place, that is equal to 1, right? This is 10 power 1 place, that is equal to 10. Now what about this one? So when we have a number after this decimal point, that one is in the negative, like this is going to be 10 power negative 1. Okay, let's write this one right here. Okay, this is the first number is 10 power negative 1, and that is equal to 1 over 10, right? And this is 10 power negative 2, that means that is 1 over 100, and this one is 10 power negative 3, that means this is 1 over 1000. Now let's go ahead and calculate this value. So here we have, let's start from the backward. 10 power negative 3, that is 1 over 1000. 1 over 1000 times 4 plus 1 over 100 times 1, because we have 1 in that place, plus 1 over 10 times 2, 1 over 10 times 2, plus 5 times 1, because 5 is in the 1st place, and then 1 times, like 10 times 1, or 1 times 10. So from this one you can see, if you calculate and add them together you will get this number back, 15.214. Now we looked at the places, right? So this is for decimal, this is the one we use in daily life, but for computers they use binary. So the maximum number it can have is 1, because if you look at the decimal, the maximum number we can have is 9, right? 9 is the maximum number in the decimal, because 1 less number than the base. For decimal the base is 10, 1 less number than the base, that is 9. So 9 is the maximum number we can have. Now let's look at the decimal numbers. I mean not decimal, binary. Okay, now we are going to see binary numbers. This is binary. For binary, base is 2, so the maximum number we can have is 1 less than the base. So we can have 0 and 1, those are the only two possibilities. Now let's look at a number. Let's say we have a number that is 101. Now if we want to find out this one in decimal, let's see how we can do it. Similar to the one we looked at in the decimal, this one represents 2 power 0, that's equal to 1, and this one represents 2 power 1, that's equal to 2, and this one represents 2 power 2, that is equal to 4, and this one represents 2 power 3, that is equal to 8, and this one represents 2 power 4, that is equal to 16, and this one represents 2 power 5, that is equal to 32. And if you add them together, if you start from here, 2 power 0 is 1, 1 times 1 plus 2 times 0 plus 4 times 1 plus 8 times 1 plus 16 times 0 plus 32 times 1, 32 times 1, and if you add them together, you are going to get 45, because we will get, let's write the numbers first, because we will get 1 plus 0 plus 4 plus 8 plus 0 plus 32. 1 times 1 1, 2 times 0 0, 4 times 1 4, 8 times 1 8, 16 times 0 0, and then 32 times 1 32. If you add them together, you will get 45. So this is the conversion from binary to decimal. For example, in the exam they may ask, convert this one into decimal, like 1 0 1 1 0 1 base 2, and they will put a bracket like this, and the base is 10, and the answer here should be 45, right? And that's how we convert a binary number from, like we convert a number from binary to decimal. Now let's look at a number with a fraction with decimal point. Okay, let's get rid of this one. Okay, so let's continue here. So let's say we have a number 101.11 basis 2. Similar to the one we looked at in decimal, this is 2 power 0, but as we go backward, this is going to be 2 power negative 1, 2 power negative 2. So we start from here. This is 2 power negative 2, right? Because this one was 2 power, like 2 power 0, 2 power negative 1, 2 power negative 2. 2 power negative 2 mean 1 over 2 square, that's 1 over 4. And this one is going to be 2 power negative 1, that's equal to 1 over 2. And this one is 2 power 0, that is equal to 1. And this one is 2 power 1, that's equal to 2. And this one is 2 power 2, that is equal to 4. Now let's go ahead and add them together. So this is going to be 1 over 4 times 1 plus 1 over 2 times 1 plus 1 times 1 plus 2 times 0 plus 4 times 1. Okay, let's go ahead and add them together. So this is going to be 1 over 4 plus 1 over 2 plus 1 plus 4. So this is going to give us 5 plus 3 over 4. So we are going to have 5 3 over 4, that's going to give us 5.75, and that's going to be the value we are going to get from here. That's how we convert this binary number to decimal number, and that's how we do this. I hope this helps. Thanks for watching.